Next up from that, you can also be told to derive a quadratic expression from a given quadratic expression and given roots. So remember with the first example that we started with ax squared plus bx, plus bx plus c, which is equal to 0. Then I assumed my ax was equal to 1, and then I assumed my x was equal to 2. That is in the very first example. And then I was able to get back to my equation from the x values. Now let's say they tell you to say, okay, assuming that you have this expression that says 2x minus 3x squared. Oh, sorry, let me put the squared here, and then let me just put the x here, 3x, and then minus 5 is equal to 0. Try and find the quadratic equation whose roots are alpha squared and beta squared. Let me just have it like that, alpha squared and beta squared. So these are the roots that we've been given. So what do I need to do? Remember, I need to find the products of the roots, and what else? The sum of the roots. Why do I need to find the products of the roots and sum of the roots? Because for every general quadratic expression, it's always expressed in the form of x squared minus c in brackets alpha plus beta, this x, and then plus alpha beta. So in short, what I'm trying to say is x squared minus in here sum of the roots, x, and then plus here products of the roots. So if I find my sum, if I find my product, I can just put the value here and here, then I have my expression. So this is why knowing how to find the values is important for you to reach at this step. So let us get rid of that and dive into the solvents. So we've been told to say the quadratic expression, we are told to find a quadratic expression whose roots are alpha squared and beta squared. So let me start by finding the sum of the roots. But before finding the sum of the roots, I need to find the sum of the original roots that we know, the sum of alpha plus beta and alpha beta. These guys I'm just always supposed to find them. So alpha plus beta, we know it's negative b over a, and then this guy is here, it's c over a. So what is my a? This is my a, this is my b, this is my c. So my b is negative 3, so here it's going to be positive 3 over 2. That is my sum of my roots. And then products of my roots, that's going to be negative 5 over 2. That's going to be my products of my roots. So I can get rid of this here. And there I'm going to have my sum, and there I'm going to have my product there. So let me not touch that. So I can go on by saying, alright, so I have that already in mind, and then they've given me the roots, which are alpha squared and beta squared. So I need to now find the sum of these two roots that have been given. So the sum of these two roots is alpha squared plus beta squared. So I need to find the value of alpha squared and beta squared. So remember that there's an identity for this. So we went through deriving this identity. So I'm just going to write the identity. And the identity says I can replace alpha squared plus beta squared with alpha plus beta squared, like that, and then minus 2 alpha beta. And then from there, what do I say? I can replace what's there and what's there. So replacing in the alpha plus beta, I can say 3 over 2 squared minus 2 negative 5 over 2 there. So it's going to be 9 over 4, and then plus a comma 5. Okay, now this one I just have to finish. Alright, so this is over 4. 4 into 4, that's 1, so it's going to be negative 1 there. This into that, that's 4, and that's going to be plus 20. So this is going to give you positive 11 over 4. So positive 11 over 4 is the sum of my given roots. Positive 11 over 4 is the sum of my given roots. So let me get rid of my solvents so that I create more space for the new solvents, because I need to now find the products of the two given roots. So the products of the two given roots are going to be alpha squared, b multiplied by beta squared. So this is just going to be alpha squared, beta squared. Since the squared are there, I can say alpha beta, and then I just square them there. So what's my alpha beta? My alpha beta is negative 5. Negative 5 to squared like that. So it's going to be 25 over 4. Positive 25 over 4. So I now have positive 25 over 4, and then I also have 11 over 4. So I can wrap everything there. I now have the freedom to wrap these guys there because I've already used them to my satisfaction. And then I can now say, all right, my general expression for all the quadratic equations should be x squared minus sum of my roots, x plus product of my root. I close. I'm going to say x squared minus, what's my sum of my roots here? This was my sum of my roots, which was 11 over 4. What's my products of my roots? Products of my roots was 25 over 4. So I'm going to say x squared minus 11 over 4, x plus 25 over 4. I can end here, I can say this is equal to 0. I can end here, or I can see to say, okay, palifo, so I can multiply throughout by what? By 4. Once I multiply out throughout by 4, the answer should be something like 4x squared minus 11x plus 25 is equal to 0. So this is my quadratic equation whose roots are alpha squared and beta squared. And we're done.